So in this question, we're told that a function f is called an even function. Okay, we're defining what an even function is. It's called an even function if f of negative x equals f of x. So let's talk about what this statement means here. F of negative x and f of x. Well, remember what f of x is. F of x is usually something that you write like an equation, like f of x equals x squared. Well, the other way we write equations is like this. We say y equals x squared. And these are the two main ways you graph something. You say y equals x squared, or sometimes you say f of x equals x squared. What f of x means is the function of x. That's y. So if I say f of negative x, what I'm saying is instead of positive x, we're going to use negative x right here. Okay? And what the graph is asking, what this problem is asking you to do is it's asking you to identify the graph where f of x is the same as f of negative x. Or in other words, where the y values are the same whether or not you're in a positive x value or a negative x value. So in other words, what we're looking for is you're looking at a graph and you're saying, okay, here's a positive x value. Is the negative x value producing the exact same y value? So let's start with an example. Let's take this first graph on the top left. I'm going to take the x value of 2. Okay, there's my x value of 2, and it has a y value of 4. Now, if you go to the negative x value, that's negative 2. What's its y value? Negative 4. So this does not work. The y value is different when you have positive and negative x values. So that's not an even function. And what you need to do is you need to go through this graph and you need to look for something that has the same y value regardless of whether the x is positive or negative. So in other words, it's going to be, remember that example I just had right here? X squared would be a great example of an even function because whether it's positive x squared or negative x squared, the result is the same. This would be a symmetric function. Okay, it looks the same for positive x over here and for negative x over there. So I don't think this is symmetric, right? You see y values that are positive on one side, negative on the other. This one we talked about is not symmetric. This one, clearly not. Hey, how about this one? I see some symmetries right here. But the problem with this one is it's not symmetric for positive and negative x values. It's symmetric around this line right here. X equals negative 2. But that's not quite the symmetry we'll want. And I'll give you an example. Let's say x is equal to negative 4. Okay? X equals negative 4, that gives you y equals negative 4. So I would expect the same exact y value for a positive x over here. But actually, the y value is way down there somewhere. So this one doesn't work because although it looks symmetric, it looks like a mirror image. It's in the wrong place. It's mirror imaged around x equals negative 2 instead of this x equals 0 line right here. That's what we want. So your last option is this graph right here. And let's just double check it and verify that it's correct. If x equals 2, y equals 0. If x equals negative 2, y equals 0. It's the same thing. If x equals 1, y equals 2. If x equals negative 1, y still equals 2. So you see, it doesn't matter what x is. We're going to find the same y value on both positive and negative values of x. This is an even function.